The session is being recorded. Okay, so today we are going to talk about quadratic functions. Okay, we're going to talk about quadratic functions. Okay, now the last two sessions, the last two kinds of functions that we talked about linear functions. And linear functions are straight lines. The same way, the systems of equations that we solve were also linear, in the sense they're often called simultaneous linear equations because we're looking at two or more variables that we have to solve for. Now, this time we're going to go back to solving for one variable, and that we're going to look at a function that is not linear. It's not a straight line. That's what linear means. The function is not a straight line. Okay, I'm going to illustrate to you what kind of function we are looking at here. Okay, and I'm going to sort of draw it so that you can see what we're talking about. Right. So this is y, that is x. So now this is what we call a linear function. Okay. Please. Now in a linear function, you have a straight line. And so it's easy to look at a linear function and say, if y is, if x is 7 and y, say y is equal to 10 plus 2x. So in a linear function, it's easy to say that when x is 2, then y is 10 plus 2 times 2, which is 14. If y is 3, if x is 3, then y is 10 plus 2 times 3, which is 16. Because 2 times 3 is 6, you add that to 10. And so the value of y will always change by 2. Whenever x changes by 1, the value of y will always change by 2. So that's a linear function. But the next thing we're going to talk about today is a function that is not linear, okay? A function that is not linear. We're going to be dealing with a quadratic function, okay? And a quadratic function is one that, it can start to fall, and then it will reach a bottom, and then it will begin to rise again. Or it will start to rise, it will reach a maximum, and then it will begin to fall. The slope of a quadratic function is not so straightforward, okay? It does change in a predictable fashion. Don't get me wrong, it changes in a predictable fashion, but that change is not always constant. And I'll just draw a quadratic function so that you can see what we mean. A quadratic function can begin to fall, reach a bottom, and begin to rise. or it will rise and then begin to fall. Now think about when you throw a stone into the air. If you take a stone and throw it into the air, you can see it goes up and then it starts to come down, gets a maximum, then begins to come down, okay? So these are examples of quadratic functions. I'll give you two more examples. I'll give you two more examples of quadratic functions so that you know what we are solving for. And the ones we will solve for today can take any of those forms. Okay, let us take a quadratic function that falls and then begin to rise, okay? It applies both ways, what I'm going to illustrate now. Okay, some quadratic functions like this one that falls and then begins to rise, you can see that it falls below 0 on the x-axis, sorry, on the y-axis, and then falls below 0 and then begins to rise again. It can go both ways. All right. It rises from below 0 and then gets to a maximum, and it cuts on two sides of the x-axis. Okay. It can never cut on three sides. It cuts on at 2 points of the x-axis. Sometimes it just touches the x-axis, for example. Okay, it just touches the x-axis and then begins to go up again. And it goes both ways. It can come from the bottom, touch the x-axis at the maximum, and then begins to fall again. So you're going to see the quadratic function in different ways. So now, the question then is, how do you specify a quadratic function? Okay? And I'm going to give you some basic specifications for quadratic function, and then how to solve them and what we apply them for. It can be applied in numerous ways in business, but very often it's applied to supply and demand functions for cost analysis. We apply it to analyzing monopoly. We apply it in the analysis of competitive markets. We also apply it in the analysis of production, okay? But I'll just give you a few examples, or maybe actually just one example. But again, I will make a comparison of a similar thing for a linear function. All right, so let me then provide you an example of what a quadratic function looks like. Now, remember, I earlier illustrated a linear function. The linear function being y is equal to 10 plus 2x, which is a positively sloped linear function. How about a quadratic function? So I'll give you an example of a quadratic function, but in general, we specify a quadratic function as y, the dependent variable, equal to a x to the power 2 plus bx plus c. Okay. Now, the peculiar thing about the quadratic function is that we specify it in such a way that y is 0. Okay? So you have a x squared plus bx plus c. You can do it either way. You can just say that ax squared plus bx plus c is equal to 0. Okay? And when we say what happens, now the quadratic function is always where the first x is raised to the power 2. This is why it crosses the x-axis at a point you can see it crosses the x-axis at a point where y is 0 at 2 points. And it is because of this square here that makes it cross at these 2 points. Now, I did illustrate to you a quadratic function, the graph of a quadratic function, where the bottom of the function did not touch 0. Now, in those cases, we say that the values of x are complex. Okay, we are not going to solve complex functions today, even though some of the things that we do in business actually give rise to complex functions. Okay, they actually give rise to complex functions, but we will not solve mathematically any quadratic equations that leads to complex functions. But we will be able to use them. For example, if you are thinking about, say, the cost of production. So if you're thinking about the cost of production, typically the cost of production can never be 0. Okay, the cost of production can never be 0. It will always be something more than a 0. And so the kinds of quadratic functions that lead to cost functions, average cost functions to be specific, will always be complex. If you wanted to solve them mathematically, you get complex solutions. But we will use them without solving for the values of x. Okay. All right. So let us now the a value here is the constant value. Okay. We call that the coefficient of x. And then the b value here is also a constant value. And the c is a constant value, which is the beginning of the quadratic function. All right. So, for example, we have a function like 0 is equal to, and I'm going to give you an example that I've already set up. Say 2x squared minus 11 x minus 21. Okay, we have 2x squared minus 11x minus 21 is equal to 0. Okay, all right. So this is an example of a quadratic function. Okay, and so
I'm actually in a classroom.
Oh, okay. In this function, a is equal to 2, b is equal to minus 11, and c is equal to minus 21. So this is a quadratic function, okay? And so how do we then go about solving quadratic functions? There are 2 ways you can solve a quadratic function. There's 2 ways. I'm going to erase this and write down the 2 ways you can solve a quadratic function. I'm not going to go into the mathematical proof. You don't need it. All right. There are two ways you can solve a quadratic function. One way is by factorization. Okay. One way is by factorization, and the other way is by completing the square. Okay. Now, but every quadratic function is not easily resolved by factorization, because you may have some, what do you call it, non-real fractions involved. Okay, the fractions will always not be real fractions, and so you will not be able to solve them strictly by factorization. I mean, theoretically, you'll be able to do that, but practically, they are not easy to solve in that way. So we're going to do it the other way, okay? And so what I'm going to do is this particular function that I put up here, I will solve it by factorization, but also solve it the other way, which is by completion of the square. The theoretical illustration of completing the square is lengthy, and so I'm not going to go through it here. So let us take that function once more, okay? Let us say that we have 2x squared minus 11x minus 21 equals 0. Okay? This is our function. This is our function. And so, how do we solve it mathematically? Using factorization. Okay? How do we solve it mathematically? Using factorization. And the simple thing that I show to students, you put in your bracket here, then two brackets. All right. And so, to solve it mathematically, you have to put in the x components. You can see here that 2, there are only two ways you can make 2, okay? One is 2 times 1, okay? 2 times 1 is 2, okay? Suppose you had 6x, then you would need 3 times 2, 6 times 1, okay? If you had 15x, then you have 3 times 5 and 15 times 1, okay? If you had 20x, then you would have 4 times 5, 10 times 2, and 20 times 1. All of these will give you 20, okay? And by trial and error, you will find a solution. If you had 18x, for example, or 18x squared, sorry, not 18x, 18x squared, or 20x squared. But let us take 18x squared. Then you will need 2 times 9. You will need 3 times 6. You need 18 times 1 to solve it. Okay, so here, then you put in 2x. And then here you have x. 2x times x is equal to 2x squared. So that means one side of the solution will have 2x and the other side would have x. Like I said, if you had 18x squared, then you will try 3 times 6, you will try 18 times 1, and you will try 2 times 9. All depends on all the factors of the constant. Now, for 21, what are the 2 or 3 or 4 values that can give you 21? Okay, 7 times 3 is 1. Of course, 21 times 1 is the other one. Okay, it depends. If you had 18 over there, then you need 3 times 6 and 2 times 9, or 18 times 1. We don't know which one will do it. So 7 and 3 will go into one of these equations. Okay? 7 and 3 will go into one of these equations in such a way, and you have to combine them with the x, the 2x here and the x here, so that the sum of your multiplications will give you the middle value here. Okay. Now, for the x squared here, this 2x squared, you have to think about 2 values that when you multiply them, you will get the 2x squared. And for the constant value here is 21, then you have to get 2 values, which when you multiply them, you will get 21. When you sum them with the multiplications of the x's, you will get minus 11. So here is an example. So I'm going to say, I'm going to try minus 7 and 3. Okay. 2 times 7 is 14. Am I correct? Hey, guys. Hello.
Yes, Professor.
Thank you.
Yeah, we're here. We just keep it muted to not interrupt you.
Okay, but when I say am I correct, I want to hear the hallelujah. All right. So 2 times 7 is 21. I'm sorry,
14.
it's 14. Okay. And if you take minus 14 plus 3, you get minus 11. Okay. Because if you take 2 times 7, you get 14. If you take 3 times 1, you get 3. Is that correct?
Yeah.
So minus 7 plus 3 will give you minus 11. Okay. And so that means here we're going to have minus 7. So that minus 7 will multiply 2. And here we're going to have plus 3. And 3 times 1 will give you plus 3. So minus 14 plus 3 will give you minus 11. So this is the solution. Okay. So how does this become the solution? How does this become the solution? Now, think about this in mathematics. If you multiply 2 numbers by 0, what do you get?
0.
0. Okay. So in order to solve this problem, either 2x plus 3 is going to be a 0, equals 0, or x minus 7 will be a 0. That is to say, either x minus 7 is a 0, which case if you multiply that 0 by 2 plus 3, you get a 0. Or 2x plus 3 must be a 0. Now, you remember when we illustrated the quadratic function, like I said, the quadratic function that we're going to be solving inside the classroom here will be this kind. All right, will be that kind. So that the values of x cross y at 0 at 2 points. So you have 2 solutions. Okay, you have two solutions. You have two solutions. So if x plus 3 is a 0 or x minus 7 is a 0, that means then that x is either 3 over 2. No. Let's see. Yes, okay. A negative 3 or x is a positive 7.
Mhm.
You get that?
Yes.
Okay. So it's either x is a negative 3 or x is a positive 7. That means that if you look at this equation, okay, what you really have is for this problem, you actually have something in the neighborhood of either x is a negative 3 or it's a positive 7. So you're looking at a curve or a graph where the quadratic graph comes from the negative side of x into the positive side of x. All right. So this is the kind of graph you're looking at. Okay. So now we're going to solve the equation the other way, okay, which is more amenable to equations where you don't have x is a negative 3 over 2. Sorry, guys. Try to correct me when I'm going astray. Okay. Okay. So x is a negative 3 over 2, or x is equal to 7. Now, but many quadratic equations, I would say most of them do not easily give themselves up for simple solutions, whole numbers, or exact fractions like 3 over 2 or 4 over 7 or 7 over 4. It's not always that easy. Okay, so let us now solve the equation the other way, and you can easily use this method to solve practically all quadratic equations. Now, also, some people just don't want to go through factorization. They simply apply the formula. And okay, so let us say we try to solve it the other way. So 2x squared minus x minus 21 equals 0. Okay, so this is the equivalent of ax squared plus bx plus c is equal to 0. So the general formula for solving a quadratic without factorization all right, the formula will be that x is equal to and you can just plug in this formula when you see a quadratic equation minus b plus or minus the square root of b squared minus four AC. All of this divided by 2. All right. So if you have a quadratic equation,
Professor, isn't it 2A or 2?
2a. 2a. Thank you very much. See, I said, please correct me when I'm going astray. Divided by 2 times a. Okay. So in this case, our 2a will be 2 times 2, which is 4. Okay. And minus b will be minus times minus 11. It will be 11. So I'm going to use this formula to solve this same equation. And after we do that, then we'll go and look at one of your homework assignment problems and solve it. Okay? We'll look at one of your homework assignment problems and solve it. I'm going to wipe off this formula. Okay. All right. So x will be equal to minus b, which is minus times minus 11 plus or minus the square root of b squared, which is minus 11 squared. Okay, b squared plus minus 4ac, which is minus 4 times ac, which is 2 times minus 21. Okay. You see that I'm putting that minus 21 in the bracket so that you know we're multiplying 2 times minus 21, which is 11 plus or minus the square root of 121. 11 times 11 is 121. Am I correct?
I have a question.
Sure, sure.
When you inputted a into the formula underneath
Mm.
the square root, is it
Mhm.
supposed to be squared? So like 2x squared?
No. A is
No.
2. A is 2. Okay.
So what happens to the exponent? That's my question.
We are solving for x. Okay.
Okay.
So
Okay.
you should not be looking at the exponent. You can see that we're putting only the numbers here. For example, when you say 11, we're not doing 11x. We're doing 11. Okay, because
Okay.
that is
Okay. Sorry.
your bx. Okay, fine, no problem. Ask questions so that everybody will understand what's going on. Okay.
Okay.
So minus 11 squared is 121, and so 2 times minus 21 is 42. Am I correct?
Could you repeat
Hello?
that?
Yes,
2
Professor.
minus.
Okay, 2 times minus 21 is minus 42. Am I correct?
Yes.
Okay. Minus 42 times 4 is what? Can you do that on your calculator? What is 4 times minus 4?
168.
Okay, so minus 4 times minus 42 is 168. So that's a positive number. Okay. Plus 168. Okay. All right.
Minus 4 times 42. That will be minus 168.
But you're multiplying by minus 4.
Okay.
All right. And I'm making a point of that because it's easy to not, take note that you're multiplying by minus 4. Okay. And all of this is going to be divided by 2 times 2. That is 2 times A. All right. So it's 2 times 2, which is divided by 4. All right. Now, what we now have here is 11. We're going to be slow so that everybody plus or minus the square root of 121 plus 168 is what? What is 121 plus 168?
289.
289.
289. Okay, so we have 11 plus or minus the square root of 289, all of that divided by 4. All right? Okay. So now, what is the square root of 289? So we have that x is equal to 11 plus or minus, what is the square root of 289?
17.
17. 17 is the square root of 279, and we divide that by 4. Okay. So then we're going to have two solutions. 11 plus 17 is what?
28.
So we're going to have 28 divided by 4.
That's 7.
That's 7. or (11 minus 17 is what?
-6.
Or -6 over 4. Okay. I'm gonna erase that for sticking out there to avoid confusion. All right, so we have 28 over 4, which is 7, or a -6 over 4, which is a -3 over 2, when you divide 6 and 4 by 2. Am I correct?
So it's a -1.5.
That's right, -3 over 2. Okay, so you can see that we have obtained the same solution as when we did factorization. But like I said, all problems are not easily subjected to factorization. If you have some serious combinations of values, you still find a solution. You still get a quadratic solution, which is a non complex solution. So, but still, factorization will just not work because you will not be able to get the exact factors because the decimal places are infinite. So you will not be able to get a clean factor like -3 over 2 or 28 over 4, which is 7. All right. So now I'm going to now take one of your homework assignments and show you how a practical business problem can set itself up to be a quadratic function. All right. And there are many kinds of problems.
One question.
Sure.
It says one of the problems, it says we must use Excel.
Yes, because
solve?
Excel would also provide you a solution. Well, in this day and age of Excel, you have those easy ways of actually finding the solution to a problem. The reason I want you to use Excel is that I want you to illustrate for yourself the graph of a quadratic function.
That's what I struggle with. I think I got it wrong in the last time we had to use Excel to graph as well.
Okay, so maybe one of the things that you should raise in some of these office hours is how to make Excel easy for you to understand what they're doing. Because yes, I see students plotting charts that are not correct, trying to use Excel, and I can understand why it's happening.
Okay. All right.
Okay.
Maybe for the next one or whenever
Yes.
you can
As
fit
soon
it
as
in.
we
Thank
come
you.
in next time, raise the question.
Sure.
Okay. And we're gonna go
Sure,
through
I will
that
do.
first. Okay. All right. So
Thank
let's
you.
look at one of your homework assignment problems and set it up in such a way that you can easily solve it. So I will share my screen. Okay, so can you see the problem?
Yes, Professor.
All right, so this is a problem that easily can be subjected to a quadratic solution. Now, you remember when we did what do you call it? When we did linear functions and we did break even, okay, there was one break even point, okay, just one break even point. And it was on a linear function, and I'm going to illustrate that for you. And I said, in this particular problem, of course, I say using Excel, what is the range of cell phones they should produce each day so there is profit, okay? And I can see where I say using Excel. So I'm going to put up an Excel solution to this, okay? I'm going to put up an Excel solution so that you can see what we mean. Nevertheless, I'm going to solve it in the quadratic equation. All right, so now remember that when we talk about a profit, the profit of a business, the profit of a business is found by revenue minus cost, okay? So let us look at this and say profit is equal to revenue minus cost, all right? Isn't that the formula for profit? Okay, so in this particular business, let's make this proper. Okay, so that you can see that the revenue function is quadratic and the cost function is also quadratic. But in fact, this particular cost function, if you try, this is the total cost. C is total cost, okay? If you divide C by Q, then you will get an average cost. And that average cost is going to look quadratic. But even this cost function is quadratic by itself, okay? It's quadratic. And usually, if you try to solve the average cost function, you get a quadratic function that does not cut at 0. Okay, so but that's a story for a different day. So if profit is revenue minus cost, so that means that our profit is going to be equal to okay, our profit will be equal to revenue, which is that minus our cost. This is our cost. All right. So it will be revenue minus cost. Okay. So when we break this open, what do we have? This will be equal to We take this revenue minus HQ squared. Now minus times minus 600 will become A plus A plus 600Q and minus times minus 21,500 will be a minus 21,500. All right. So what do we have? Minus 3Q squared minus 8Q squared will be equal to minus 11.
Minus,
Okay, were you gonna say something?
go ahead, Professor.
Okay. Well, minus 11Q squared. Okay. Okay. And then plus 480 plus 600 will be plus 1080 times Q minus 21,500. So you see now you have a quadratic solution. A quadratic solution. Now you can solve this by using the quadratic method, okay, that we have. It's going to give rise to some very big numbers. So I'm not going to do it here, but what I'm going to do right now, I can see why somebody was asking that question, to use Excel to solve the problem. So I'm going to do an Excel for you. And if need be, then maybe next time we'll go through the quadratic solution just to illustrate that point for you. But I think it would be better if I started all by itself and give you the solution so that we don't go through the trial and error right here. Okay.
Okay.
So I'm going to
Thank you.
I'm going to pull up the Excel file, and I'm going to take this and put it in Excel so that you can see exactly how to do it on Excel. I'm going to copy the equation. I'll stop share. Okay, see my all right. So this is the equation. Okay. So all you have to do here is to come in here, put your y. Okay. And here you have your x. All right. So I'm looking at the range of values here. Okay. Actually, I should use Q since that is what we have here. Q is the independent variable. Y is the dependent variable. I'm looking at possible solutions here from possible outputs from 0 outputs. And so I'm going to take a range of values. I'm going to start from 0, since there's a fixed cost of 0. I'm sorry, since there's a fixed cost and your profit will be 0 at that fixed cost. Okay. If you produce 0, your revenue will be minus 21,000. And so I'm going to say take ranges of values. I'm going to start from 5 and see if we find a solution. Okay, so I can see I'm going from ranges of 0, 5, 10, 15, 20, 25. And I might just change it as we go. I can start from 2. Okay, maybe I can use 2 as differences in output. But in a real world solution, you probably just have ones. Okay, so let's see. Okay, we may not get a solution using ranges of 2, can go to higher value. Now, so what you do then is you put in these values here and say equals minus 11 to the power 2. I'm going to make that bold so that you can see it. Okay. All right. You can see here already minus 11 to the power 2 is 121, but that's not what we're doing. Minus 11 to the power 2 plus 1080. Actually, excuse me. It's minus 11 to the power 2 times I6 star I6 plus minus 11 to the power 2 star I6. Okay. That I6. Okay. All right. Plus 10080 star I6. And why am I saying I6? Because the quantities are in column I. And we are starting from 6. Okay, so it's I6. Okay. Then minus and all of this. And see, you have to go through a process. And all of this minus 21,500. So you put in the formula there, and you can see automatically you have a loss of 21,500 if you produce nothing. If you sell nothing, your loss will be your, what do you call it? Your fixed cost, okay? And I'm going to then drag this down and see what happens. Okay. Okay, so do you see what we have here? Does everybody see what's going on there?
Yes, Professor.
I just drag it down. And so if you produce and sell nothing, your loss will be your fixed cost, right? Your loss will be your fixed cost. You see right here, okay? I'm going to, if you produce and sell nothing, your loss will be a fixed cost of 21,500. That's what's gonna happen, all right? Okay. If you produce only 2 units, okay, maybe we could have gone from 1 to, maybe I should use 1 here, okay, and well, let me go back to what we have. Because then, okay. So if you produce only 4, you are still losing money. But at what point do you go from negative profit? Remember, this is your profit. Okay. This is your quantity of output. All right. All right. So when you produce nothing, you lose money. You produce 2, you're losing money. You produce 4, you're losing money. Produce 8, you're losing money. You produce 14, you're losing money. You produce 16, you're losing money. At what point did you start making a profit?
From 18.
From when you produce actually between 17 and 18. Am I correct? I mean, between 16 and 18, yes. Which is probably somewhere in 17. Am I correct?
Yes, Professor.
Okay. So you must produce 18 at least to begin to make money, right?
Mm-hmm.
And if you keep going, there's a point, and I'm going to keep going and see if we start losing money again. Okay.
Still positive.
Okay, so we didn't get to that point here, but you can see here that you start from losing money. Let me shut this one off. All right. So this is one of those quadratic functions where you get to a certain bottom and then you may not begin to rise again. But this is how to do it in Excel. And then you can plot a graph with it, okay? And the graph will show you And the graph will show you at what do you call it? At what point you start gaining money and at what point you start losing money again. Okay, so you're going to have two solutions. But next time, because these numbers are big, I'm going to show you a solution that by hand so that you would get at the right kind of solution. All right. Okay. So at this point, I'm going to stop and ask if anybody has any other questions.
Yes, Professor.
Okay, go ahead.
My question is pertaining how you submit the assignment.
It's submitted on Blackboard as usual. You submit it through the link.
Yes, I understand that, but what I didn't understand is you said because since we were working with Word and Excel, you don't want like too many links.
Okay, so what I said is you can have the two links. I would like to see, as a matter of fact, I would like to see your Excel solution as well as a Word solution. It's very, very easy. You submit two files. What you do is when you submit the first file, instead of saying submit, you choose another file. Okay.
Okay, and upload it at one time instead of multiple times.
Yes.
Okay.
So I mean, you don't need two submissions. When you submit, I want to stop share. Okay, let me pull up. Let me share your screen. Okay, so this is the homework problem. And so you go over there. And so you upload your files here, right? That file is there, right?
Okay. Mm-hmm.
And then you go back, pick another file. The second file is there, and then you submit.
Okay, I get you.
All right. Then you submit. Now, if you haven't finished the other one, you can simply say save draft and you can go back. But otherwise, it's much better you do everything and you go and browse again and open again until you have all your files and then you submit.
I have another question.
Sure.
Do you mind if, like, for example, I use Microsoft Word, right? And then the part that I have to include Excel, do you mind if I like upload a link for the Excel on the Microsoft Word?
No. Submit them as two separate files. Sometimes the links won't work.
Okay.
Okay.
All right, I'm waiting to speak to you alone, Professor, if you don't mind.
Okay, so then everybody else, you can go. Thanks for stopping by.
Thank you.
So I will speak with what is that, Gomez?
Yes, Mario.
Okay. Okay, I'm gonna stop the recording.